So if you have something inside your log that's being multiplied, you can change that into log of A and log of B.
And to apply the rule, you could expand this into log of 2 plus log of x.
So if you have something inside the log that's being divided, you can do log A minus log B. That's it.
And to apply the rule, you could expand this as log of 2 minus log of x.
Being raised to some power, you can get that power and bring it out to the front, so it would look like B of log base A.
To apply the rule, you could write it as 2 times log of x.
Log can have any base, but if the variable is 1, it's always going to equal 0.
To apply the rule, when it's 1, it's always going to be equal to 0.
So now we are going to apply some of our rules to solve this problem. First, she's going to start by expanding it, the division into subtraction. So it's going to be log base 3 of 9x to the 4th minus log base 3 of y to the 1/2. Next, she is going to expand the multiplication to addition, log base 3 of 9 plus log base 3 of x to the 4th minus log base 3 of y to the 1/2. After that, she's going to bring the exponents to the front. So she's going to bring the 4 over in front of the log base 3 and the 1/2 in front of this log base 3. Then she's going to solve for any logs, and since log base 3 to the 9 is 2, then that's the answer, and you just, simplify.
Exponents have the same base, you could just add the exponents.
So there's an example right here. These problems have the same base, and since it's a multiplication problem, we would add the bases here. So for example, it would be x 2 plus 7, which in essence would equal x plus 9.
So if the bases are being divided by different exponents, then it would equal base and the first exponent minus the second exponent.
In this problem here, eventually what we're going to do is subtract the exponents. So it's going to come out as x 10 minus 9, which will result as x to the first.
So if an exponent with a base is being raised to another exponent, then you just multiply it, so it becomes x and a times b.
Here, the inside variable being raised to the 7th power with an outside exponent to the 2nd power. So eventually this exponent, this problem is going to turn into 7 times 2, which will equal x to the 14th power.
So if you raise any base to the exponent of 0, it will always equal 1.
This problem right here, eventually it would be converted to 1 over x to the 2nd power.
Go.
So if the base is raised to a negative exponent, it becomes 1 over the base and the exponent.
So in this problem right here, we have 1,000,000 to the 0th power. If it's always 0, it'll always equal 1.